Having the relational database, just to describe what it's about and its main elements. Firstly, the relational database comprises of many different tables, which are typically describe one entity, like a student or a school. Then every table has many attributes, like your student name or student surname, which describes the table itself, which is where the data is stored for every specific row. Now, every table has its attributes, and all those attributes are displayed in many different rows. And there can be many rows in a table. One row can be, as we have here, John White, which is the student name, and another row can be Mary Beth, which is the second row in one table. So the information in the table can be different, but they all have the same attributes, and they all relate to a student, to one entity. Then every table has one unique key that describes the information of this one entity in another entity, which creates relationships, which gives the database its name, the relational database. And a primary key that is used in another table becomes a foreign key, which is where our link comes from. The relational database usually uses a crowfoot notation, where the mini sign looks like a crow's foot. There are three types of relationships, being a one-to-one, one-to-many, and many-to-many. This one in particular is a one-to-many relationship, meaning that a school can have many students, but a student can only belong to one school. And that is the relationship of these two tables, but there can be many other different tables. The relational database is very simplistic, and that is why it is predominant in all the databases and mostly used. It is accessed by SQL, which is a structured query language, and the SQL is used to manipulate the data, unlike object orientation, where methods are used to manipulate the data.
I'll talk about the object-oriented database. So what the object-oriented database is, it actually has classes and objects and attributes. So here we see the video class, which actually has a TV format, has the object and a DVD and a quick line. Then the attributes that actually describe the database will be a screenshot, director, or the title of that movie, or if it was a TV, if it's an episode that shows that. So object-oriented database store objects rather than data, such as strings, integers, and real numbers. They are used for object-oriented languages such as C++, Java. Compared to a relational database stores data into tables. The data have rows and columns which they actually store the data. And all columns have a primary key to identify. Once a specific column is identified, data from one row or more associated with that column may be obtained or changed. So to put objects into a relational database, they must be described of simple string, such as this. So this is what you actually store in a relational database. They should be used when there is complex data or complex relationships. This includes many-to-many object relationships. They should not be used when there would be a few joins and tables and large volumes of simple transactional data. They actually work well with multimedia applications. There are advantages and disadvantages. They have reduced parsing, easier navigation, better concurrency control. The disadvantages would be lower efficiency when data is simple. Relational tables are simpler. Late binding is low.
I'm doing the data warehousing, and I'll just begin by giving a brief overview of what a data warehouse is. The term data warehouse was first coined by Bill Inman in 1990, according to Inman. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data. This data helps analysts to take informed decisions in an organization. An operational database undergoes frequent changes on a daily basis on an account of the transactions that take place. This is basically what a data warehouse looks like in an illustrative form. We have the data sources which feed into the data warehouse, which, as mentioned before, stores all the various historical data that the organization has over time collected. And then here we have data marts, which I'll go into further detail a bit later on, which does the basic functions that the data is operated on. So this is where the analytical processes take place. This is where the business executives, as they say, would come and mine data information and analyze the actual information that is stored within the database and within the data warehouse. Our query manager is established in a data warehouse. We have the user which interacts with the query manager, and this is an ongoing process that takes place within the query manager, where firstly the query is redirected, and then it goes into the metadata, which then feeds back into the stored procedures, and that process then carries on and goes into the query management tool, which then it will give us detailed information, and after that it goes to the query scheduling, which basically manages when each query will be handed back to us, and from that we will get a summary information.
SQL database. So what is it? NoSQL database, as the name may suggest, is a database that is not based on SQL. It is distributed, open source, and supports horizontal scaling. The term NoSQL can be misleading to many, as they may think that it does not support SQL at all, but this is not true. NoSQL can be expanded to mean not only SQL, which means the database, although it is not relational, can support SQL. NoSQL databases have data that is not relational, and usually have no schema and less consistent modules compared to the traditional relational databases. So where does NoSQL come from? It first emerged as many internet companies such as Facebook, Google, Amazon, LinkedIn, Yahoo, and many others struggled to deal with unprecedented data and operation volumes under latency consistency. They needed a database that could store and process large amounts of data with little to no latency in real time. So then, how is it different to other database types? NoSQL databases are categorized by the BASE acronym, unlike its other counterparts, which are categorized by ACID acronym. BASE stands for basically available, soft state, eventually consistent. NoSQL is most similar to the data house database, as they both have to store huge amount of data. The only difference being that the NoSQL does not have to analyze, it only just has to access. It has to store and process as the application wants it. It is also similar to the object-oriented database, as it can also store objects as it can store data as objects for object-oriented programming. NoSQL is a revolutionary and is very important in today's internet-dependent world, where everything is quick and has to be in real time.